Okay, so hi everybody. This is 2002 called. They want their RRD tool shell scripts back, and I'm Dave Josephsen. Once again, I'm going to apologize for the title. Like I said, I was punchy that day, I guess, and I'm not sure what I was mad at, but it definitely wasn't you guys. And this one I don't really have an excuse for, so I decided that I was going to change its name spontaneously to A Brief History of Time Series Data Visualization Architectures, which is more, it's wordier and it sounds kind of boring. And I actually did, I sat down to try to make these slides, and I discovered that there's an awful lot of stuff I want to talk to you guys about today. And there was no way that I was going to be able to like timeline it, like, you know, we start here, end there, and, you know, here's everything that happened. And really, the point of the talk is not to give you the history of time series visualization. It's more to express to you that there's a lot of ways to skin this cat nowadays. And what I've observed or been observing is that we all seem to be doing it the same way. And I just mean Nagios community people in general. We all seem to be kind of doing the same thing with the same tools, and there are actually some really cool tools out there, and I just wanted to make sure that everybody knew they were there. So I'm changing the name of this talk a third time, and what I'm going to do is I'm going to tell you 3 anecdotes or scenarios, if we want to be more official, I guess. And I thought I'll tell you, 3 stories about 3 different sysadmin, and I will sort of accentuate these scenarios in such a way as to make them very different from each other. And so you can see like where an admin might choose one tool over another, or like what sorts of situations would make people choose these things. And I thought it would be really fun if I used some of my friends to do this. So this is what sysadmin look like in Texas. Well, actually, that's not fair. This guy in the middle is Danish. So he lives and works in Denmark, and we see him at conferences every year or so. And that's Per. So the outside 2 are what sysadmin look like in Texas, and in the middle there, that's what happens when Danish people hang out with Texans for too long. So the only problem here is that my friends don't actually match up to the scenario concept, right? Like they don't have jobs that are wildly different from each other. They all pretty much do the same thing, except one of them does it like 6,000 miles away. So I'm basically making up lies about my friends, and since I feel bad about that, I thought I would start each one of these scenarios with an actual story about my friends, and that way, well, I think they'd want me to. So I'm going to start out with Jer, and Jer is pretty much doing what most of us, I think, are doing today. This will be a pretty quick one. The true story I want to tell you about Jer, and you have to look at the expression on his face when I tell you this story, because it's totally the expression he carries with him everywhere. I mean, that's like when he proposed to his wife, that's totally the expression he had on his face. And so the story I want to tell you is like this epic like battle of wits he had. Well, from his perspective, it wasn't a battle of wits. It was more like being asked the same stupid question over and over and over again and always giving the same answer, which was no. But he worked for a very large company that had a problem. The problem was that their single sign-on product didn't work. And nobody can make it work, and all the king's horses and all the king's men. And so they came around to figuring out, like, who are we going to fire over this? Like, who do we like the least? And, look at Jer. You know what I mean? Like, look at him. So they're like, yeah, well, we'll give it to Jeremy. And then when he can't make it work, we'll fire him, and then everybody will be cool. And so they drop this thing on Jer, and not only does he have it working the very next day, he's formed, like, rough coalitions between, like, all of the various groups that, were required to get single sign-on working. And, they all love him to the extent that, like, he literally has, like, a desk in their area that he can sit at whenever he wants. And it's, it's all just working fine. But it is kind of a house of cards. It's, it's sort of an intricate and delicate sort of solution. And Jer is pretty much the only one who knows how it works, and he's the only one with access. And this kind of ran afoul of the security manager at the time, who was sort of very excited to be getting access to this, single sign-on solution. At which point Jeremy said no. Just like that. See him? No. Can you see him? And so, and the security manager escalated and escalated and escalated it, and it, like every couple months, Jer would be pulled into these meetings with all of these CIOs and VPs and, whatnot. And they would be like, hey, we're here because, security manager needs access to that single sign-on solution. And Jer's like, no. And it went on for years. I mean, it literally went on for years until one day, Jer became an employee of the security manager, actually joined the security team, went from like web to security. And now, it's the day of reckoning, right? And this security manager is like, sits him down in the office on his like very first meeting, very first day, and is like, so, gonna need access to that single sign-on solution. No. And yeah, totally didn't give it to him. I love that guy. He's so awesome. Anyway, so here's the scenario I made up for Jer. Jer is one of 3 sysadmin at SuitCorp. I wrote these down, by the way, so that I wouldn't forget them. He's a sysadmin at SuitCorp, a Fortune 500 style company with less than 5,000 servers. His environment is all on site in a 1-story or a 9-story office building. Sorry, consists of a hodgepodge of Windows AIX and a few Linux boxes here and there. He's been using Nagios to monitor system and service availability and is monitoring fewer than 20,000 services on a beefy 2U system. The SuitCorp CIO, who recently moved casual Friday to Tuesday, just to see if anybody reads his email, gave Jer a healthy stipend to replace his monitoring system because he read in the current issue of CIO magazine that grown-up monitoring systems always have integrated time series visualization. So Jer's not worried about it. He's sitting there, sitting pretty. He has a healthy budget with which he bought like a 3U system. He's running about a minute and a half per 1,000 hosts. So his polling interval is up about 6-7 minutes, maybe 8 minutes, right? Polling interval. And what he wants to do is he just wants to add time series visualization. So he's going to do probably what about 90% of the people in this room have already done. He's going to make his decision between Nagios Graph and PNP. And he's going to use Nagios. He's going to use the performance data hooks in Nagios. He's going to send them to Nagios Graph, which is a Perl script. It's sort of arbitrary. PNP, Nagios Graph. It's like there's very little difference between the two of them. I think they're both in Perl. I'm not sure PNP is. Is PNP for Perl? Is it? Yeah. So they're both Perl scripts. Nagios Graph, maybe he chooses Nagios Graph because PNP doesn't support plugins that don't have performance data, and he doesn't want to write wrappers for his plugins. But it's really not a big deal either way. So NG pushes to RRD tool, and then all Jer has to worry about is how he's going to present it. He can use the built-in Nagios Graph interface, or he can get something external like Draw, which will let him take those graphs and maybe make his own interface with them. And then the clients come to his interface and they read them. And this is I think pretty much where we all are. I even put ho-hum in the slide, like, isn't this boring? We all know this, right? Do we all know this, by the way? We all pretty much here? More or less. This is pair. And I love this picture of pair because it's like the anti-pair. It's completely opposite of pair. And what he's brandishing at you there is a fiberglass reinforced nylon shank, which the last time we were at Lisa, it happened to be Pair's birthday. And you may not know this, but in Denmark, knives have become illegal. So the Danish are like literally not allowed to have pocket knives, and like if you went to IKEA, sorry, that's racist. No, I'm just kidding. If you went to like the department store and you bought some steak knives and you took them home and you like get caught like on the way home with your steak knives, it could be like a problem for you, which we Texans think is hilarious. We were actually issued Bowie knives in 3rd grade, so clearly we thought what Pair needed for his birthday was a fiberglass reinforced nylon shiv. And these are great. They go right past metal detectors, or so I hear. And they work just as well as real shivs, or so I hear. We gave that to him and challenged him with smuggling it into his home country, which he did. He totally did, by the way. Love that guy. So this is him cracking up at having unwrapped the shiv, and then showing us his inner psychopath. Anyway, so the scenario for Pair is that he is a Danish sysadmin working in Austria for Singularity.gov, where an international group of super scientists compete to destroy the universe by colliding particles into each other at high speeds, in the hope that they will create an antimatter explosion, or failing that, a large enough singularity to get things going in the right direction. Pair is the sole sysadmin for 80,000 computer nodes, organized into 80 clusters of 1,000 nodes each, and this is made possible by the prodigious use of automation, a configuration management system, and the fact that all nodes are exactly the same because they all work in parallel to form one big supercomputer, created for a single, very specific purpose, particle collision analysis. Pair is in a bad spot. He's working in hardcore academia with no management infrastructure. They don't have a budget that they won't use for particle system analysis. It's all they want to do all the time. He can't really even schedule meetings with them because they're scientists and all they want to talk about is particle analysis. The universe isn't going to destroy itself. Like we really have to, any moment spent not destroying the universe is a moment not spent destroying the universe. So clearly he also has some problems. Even though he does manage to scrape together, a one-use system and put Nagios on it, the polling interval is going to be way too large for what the scientists want, right? Like he needs a polling interval down into the 15-second range. Nagios is going to be up in the minutes. But at the same time, he doesn't want to get away from Nagios because he also wants to check CPU, memory, disk, net thresholds and alert when they get too large in various parts of the cluster. So this scenario was pretty much custom tailored to introduce you to a tool called Ganglia. Fair warning, I'm a Ganglia developer. I love this tool. It's wonderful. Super intelligent design. So the way it works, there's three parts. gmond is, yes, an agent that runs on every node that you want to monitor, and we're sorry about that. gmetad is a metadaemon that collects data from each gmond node, and gweb is a front-end web presentation tier. So the way this works is all of your hosts are organized into clusters, and clusters can be whatever you want them to be. They can denote like physical, location, or they can be like network subnets, whatever. Every host that shares a cluster multicasts its state to every other node that's in the same cluster. So in this way, every gmond node knows the state of the entire cluster to which it belongs. Okay, does that make sense? So all you have to do is ask any single gmond node in a cluster the state of the cluster, and it will state dump to you the entire cluster. And gmond is a super efficient agent. It's written in C. It uses very terse XDR protocols to communicate, to do inter-host communication. It adds like zero, like out of the box, I should say. It adds zero load to your boxes. There are ways to break that, of course, if you start introducing your own scripts and whatnot. But it has a plug-in architecture, very similar to NEB, where you can write your own metric measurements. And just out of the box, it'll get you the big four, plus a whole bunch of stuff that you probably might not be getting now. So you get your CPU, your RAM, your disk I/O, you get disk space, you get all kinds of service stuff. And the offset is that the problem of scale, right? The thing that was causing you problems with Nagios becomes the solution when you're using Ganglia. So like this solution scales linear with the number of hosts you add. Every time you add a host to a central polling system like a Nagios, it makes Nagios work harder. Every time you add a new node to a Ganglia cluster, the cluster runs more efficiently because the load is distributed throughout the cluster, right? So it's sort of like this, it's a distributed architecture built-in mechanism for measuring metrics on large groups of machines. And it scales to several 100,000 hosts without even breathing hard. And then when you get up there, we can do interesting stuff. You tell gmetad, you say, hey gmetad, here are all my clusters, I enumerate them. And here's like the first, depending on how big your clusters are, if you're running 1,000 node clusters, go ahead and give it like 7. If you're running like 100 node clusters, give it 3. And gmetad will go out every so many seconds and it'll pick one of those nodes that you told it about. It'll grab the entire machine state from the cluster and write it, RRD cache D, straight to an RRD directory structure. And it can do bulk updates with RRD cache D, like I just said. Repeating myself already. So this is a really great distributed system just all by itself. Just right there, if you were looking to get all of your data off of an enormous amount of boxes into RRDs, and then you'll take it from there, it's an excellent solution. On top of it, you get, in my opinion, the best RRD tool web front end in existence today. It's an amazing analysis front end. It's written in PHP. It has oodles of functionality. I thought I had a slide about it, but maybe it's the next one. So here's all the stuff that I just said in text form. Oh, and I forgot to mention, it also includes 5 Nagios plugins. So these are actually supported by Ganglia developers, Nagios plugins intended for Nagios people, because we all use Nagios too, that make it possible from Nagios to check thresholds in Ganglia. So if your Ganglia box is recording the CPU and you want CPU threshold checks, you can just point Nagios straight over at gmetad with the included plugin. Gmetad will literally just tell you, hey, yeah, here's your threshold. And you can do that for individual metrics on individual boxes, multiple metrics on multiple boxes, multiple metrics on multiple, all that stuff. Here, the sub things. You can do all those. Also included is a check host heartbeat, which works pretty well as a replacement to check ping. So you can set your check host and check ping service definitions to a Ganglia plugin and just ask gmetad, hey, when was the last time you had data from this host? And if it was more than 15 seconds, then you get your alert. It works extremely well. And a lot of people just in general have, and I myself am one of these, and especially older guys, I think, we have this sort of line in our head between what constitutes performance data and what constitutes availability data. And I think for most of us, Nagios works great as an availability system. It may not have the resolution that we want right out of the box as a metrics analysis and gathering and polling engine, right? So this is awesome. You can very easily separate out the performance data part from the availability part and still have really great integration between them. So it's not just for mad scientists and supercomputers. I use this, and I'm just a normal business guy. Anytime you want to offload performance data processing, it's just getting too heavy. If you're wanting, nearer real-time data, better resolution for your metrics, or you're looking for a there's the thing with this stuff. So yeah, the GWeb front end literally drag scaling. So you've seen this in Cacti, where you can go into the RRD tool, drag across, and get zoom in. Supports that. Supports trend lines, which are it's like, hey RRD tool, tell me if there's a trend here. It's the one that you see down there at the bottom. So we have a disk graph, and you can tell GWeb, hey GWeb, hey, is there a trend happening here? And GWeb will literally draw a line for you. Holt-Winters forecasting is built in, so exponential smoothing. Yeah, exponential smoothing. No. This is it's Holt-Winters forecasting. It's, hey, is the next data point statistically aberrant given the history of my other data points, right? Time shifting is in here, so I can say very easily on the same graph, I can graph something, and then I can say, hey, what is this metric doing 2 weeks ago? And have another graph that's the yellow one there that you can see with the sort of highlighted part. So the yellow dotted line is, what was happening 5 days ago to the same data set at the same time. It's a really, really great RRD tool analysis front end. I haven't seen anything better. So we're getting to Dave, and I also love this picture of Dave. Quitter, I should call him. This picture was taken also at Lisa. What happened here is Dave used to work for the co-location facility that we were customers of. And when it came time to hire a Unix sysadministrator, I don't know if it's like this in your part of the world, but in my part of the world, it's difficult to find good ops people. They tend to come in and not have beards and, all sorts of weirdness. But anyway, so we thought to ourselves, instead of going through, the normal resume heck, let's pluck somebody out of the co-location facility. And we had 2 choices, and of the 2, Dave was the one actually we liked better. So we pluck him out. He's happy, we're happy. 6 months go by, and evidently the entire time he's working for us, the co-location facility is like hammering on him to come back. Corner office, stock options, company car, the whole time, right? Raise after raise, whatever he wants, they'll give to him. So 6 months later, he quits, goes back to the co-location facility, and has been known ever since by us as Quitter. And so this was at the last Lisa. I write for their magazine, so they know me. So I walked up to the registration desk a day early and I said, hey, I need to change this guy's badge name from Dave Ellis to Quitter, so that when he shows up, he'll have a Quitter badge. And they literally did this for me. They changed his name in their database. We had a whole week of fun planned for him. We had like, Quitter cake and a Quitter boff. We were going to do Quitter boff for him. And we actually went around to all the pre-boffs the night before and told everybody that we could get our hands on, hey, there's a guy walking around. If you see him, he's got Quitter on his badge. Just sort of, mutter under your breath, Quitter at him, which a few people did. But this is taken just as he's kind of realizing, like he just got his Quitter badge. It's one of my finest moments, really. He just got his Quitter badge, and he's like, he knows us, and he can see the whole week just sort of unfolding before his eyes, and he's just like, oh God, yeah. So that's when that was snapped. I did a little zoom in so you could see the Quitter badge was actually on there. So Quitter is one of umpteen thousand sysadmin at Massive Ginormic. A huge internet company whose multi-billion-dollar revenue stream is a mystery to everyone, including their shareholders. Massive Ginormic employs an army of sysadmin, software developers, and recruiters whose salaries are computed as a function of the number of PhDs they hire every week. At Massive Ginormic, there are so many servers that the sysadmin quantify them as a multiple of Avogadro's number, and the network is so distributed that entire data centers have literally burned to the ground without anyone noticing for weeks. Traditionally, internal groups at Massive Ginormic have formed ad hoc techno-fiefdoms led by individual PhD warlords. Maybe you work at a place like this. I did. Or small groups of PhD oligarchs. So each fiefdom is roughly self-contained and claims some territory in the form of production servers. They all run as much of their own infrastructure as they can, including monitoring systems. Recently, however, developers under the banner of DevOps, can I get a high five? And continuous integration have staged a company-wide coup and, laying siege to most of the feudal territory, have largely torn down the walls of access control between production servers, enabling any developer to change any application at any time, anywhere. So, and this is happening in a lot of places. So like the traditional sort of ops guy, barriers to production are kind of being routed around by this sort of DevOps attitude that says, it's cool if you can't give us a server, tomorrow we'll just go into the cloud and, create this entire exception to your infrastructure. That's worst case. I'm harshing on DevOps a little bit. It's actually not that bad when it's done correctly. It's actually a really good thing. But lately, it's kind of been not being done very, very well at a lot of places. So, and Dave is facing this nightmare. And what's happening is the developers are having stability problems and not noticing because a lot of developers are changing a lot of stuff and stability is suffering. And so they've come to Dave and they've said, hey, Dave, we know that you're into monitoring and visualization and whatnot. We would like you to come up with a visualization system for us whereby we can instrument our code to do things like time how long given functions work and or track the number of times per day that we commit a software release. We would like you to have all of that on the same graphs as you have all of your stuff, the CPUs and the memories and all of this stuff, so that we can step outside of ops and get a DevOps perspective into what's happening with our infrastructure. And this is pretty much, this breaks RRD tool. Because RRD tool is pretty pedantic about, heartbeat and step and, things have to happen in timed intervals. And code promotions in a DevOps environment and continuous integration environment do not happen on regular intervals. So clearly, he's going to need something that is agnostic to, time intervals at the very least. He's also going to need something that's going to be easier to get data into than RRD tool is, because there isn't really a good RRD tool update API, right, for like Java and PHP and Ruby and all of these systems that his DevOps people are wanting to commit, right? The other thing is, if he gives them this, they're going to add a lot. Like, if any developer at any time during the day can come up with a new function and go ahead and instrument it in such a way that it not only tracks the number of times it's been called, but also the amount of time it takes to run, you're going to have, in the company the size of Quitter's company, you're going to have millions of metrics, just right off the bat, and they're going to do nothing but grow. So there's no way he's going to be able to take requests for new metrics and do RRD tool creates. There's no way he's going to be able to script, a developer's ability to do that given the constraints of time agnosticism. It's not, we're beyond RRD tool, right? And so, yes, enter graphite. So they had RRD tool really big at the top there. I was like, wait, where am I? So enter graphite. So many of you probably heard about graphite already. It's a fantastic tool. It's written in Python. Basically, it's just it's an RRD tool replacement. It's pretty much directly engineered to be a drop-in replacement to RRD tool. They've ripped out the database backend and have replaced it with something called Whisper. They've ripped out the graphing components and have replaced them with a web UI, which is called, confusingly, Graphite. I assume they did that to make my life writing about it more difficult. And they've bolted onto the front of it a network socket interface called Carbon. And this is absolutely genius. So all you need to talk to Graphite is a tuple. You need a date stamp. Wait, is that a tuple or is that a threeple? Sorry. You need a date stamp. You need the name of the thingy that you want to measure, and you need the value of the number. These are separated by spaces. The name can be interspersed with dots to give hierarchy. So you can imagine a name like, server metrics dot DC4 dot server 18 dot memory, right? That would be the name of that whole hierarchy. And Graphite will actually break it out into a hierarchy for you and store it that way on disk. But without any pre-configuration whatsoever, you come up with a date stamp, a name, and a metric. You send it to Carbon, and Carbon will take it, cache it, talk to Whisper on the back end, provision storage for it, given some general guidelines that you give to Whisper about creating storage that have to do with naming. So like the example I just used about memory, you could tell Whisper, hey, anything that's named memory, I want to keep, and you'll be familiar with the PDPs and all that from RRD tool. I want to keep 5,600 PDPs at this resolution, blah, 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 right? So you don't have to pre-provision storage for anything. There is no RRD tool create. You send the data to the socket. If the data name matches something that you've given special instructions for, then that will be provisioned. If not, it'll match default and it'll be provisioned anyway with a default database setup. It'll be stored to the database. It'll be available immediately on the web front end. It scales massive because you can run Carbon and Whisper in parallel. So they scale horizontally. You can put them on multiple servers. Point them at each other. It's a beautiful interface. I had let's see if I didn't say anything that was on that slide. Whisper, like I said, has interval and type agnosticism. This is something we should talk about, is type agnosticism. So in RRD tool, you give types of data. You give gauge, you give derivative, you give counter, you give other data types. It's like a quiz. Internally in Whisper, all data is stored as type gauge, which might sound really bad to you right now. Like it might sound like, oh man, if I have a router counter and I'm throwing all of my data into Whisper, then all I'm going to see is a counter incrementing to infinity. Every single one of my data metrics is just going to be a higher number of that counter until the counter overflows. RRD tool handles this for us automatically because we tell RRD tool, hey, this data is type counter. And then RRD tool automatically runs the derivative and shows you a rate based on the counter, right? Whisper doesn't, and it doesn't on purpose because it doesn't want to know what kind of data you're operating on. It wants you to be able to later give it advice on how to display the data back to you. And we'll see how you do that in a minute. I actually have it written down there as functions with an exclamation mark. Everything that you ask Graphite for, you can use a wildcard. So if in my description with memory, I can ask Graphite, graph star.memory. And Graphite will give me a graph of every metric that it has on disk that has memory in it or in cache. And so it's really a game changer in ways that I find hard to describe. It really encourages you as an operations guy or as any kind of guy, as a sales guy, to explore your data. It makes it really trivial to say, I want to see this metric and that metric together. I'd like one to have a different y-axis, and I'd like there to be some sort of guideline in the middle. I'd like there to be time-shifted data in there. It's super trivial to add all of this stuff to your graphs, just sort of plugging away at the interface. And I'll show you how in a sec. So it's not just from billion-dollar mega giants. If you're wanting a centralized place for all of your graphic data, and even if you're using Ganglia, and even if you're using Nagios today, so let's start with Nagios. If you have Nagios in your performance database, you're sucking up all this performance data, but you want to repurpose it, it's a one-liner to take that performance data processing line and tee it and send it off to Carbon. You can do it with netcat. I mean, it's that easy. You literally, it's like netcat-c, single quote, and then give it the three. Help me, somebody with the tuple. Is it called a tuple? It's not, right? Tuples are two. Dying. Anyway. And Carbon will just handle it for you. With Ganglia, I actually wrote the patches for this last year. You can tell gmetad, hey gmetad, I have a Carbon server. Here's its address. And gmetad will, on top of writing everything to RRDs locally, send it to Graphite for you. Or you can turn off RRDs altogether if you don't like RRDs. gmetad can just flush all of its stuff straight into a Graphite server that you configure. Ganglia, as a matter of fact, can also use Graphite as its graph engine. So you can actually configure gweb to say, hey, gweb, I'm not using RRDs, I'm using whispers. So just do all the stuff that you normally do that's great with RRDs, except do them with whispers instead. It'll just do it. It's awesome. Also works really well if you want to take data from other places. So if you have a Salesforce or something like that, and you're wanting to get that data into somewhere that it makes sense, Graphite is a perfect place to store that data. And it's also really great. It's super trivial to write interfaces on top of Graphite or just let people use the Graphite interface itself. Admittedly, the web interface for this one, not so pretty. I like it a lot less than gweb. When I deal with it, I normally deal with it in the URL. So I'll go to Graphite web interface. I'll right-click on the graph, say open a new tab, and I'll have the URL up there. And the URL will have the parameters, and I'll change them to get what I want. I also have a shell script that does that for me, but that's mostly how I interact with it. And you'll see in my examples here, that's what I'm kind of giving you in the gray areas. I'm giving you basically the CGI context, or the CGI syntax. So these are some Graphite graphs. Basically, I've gone to the Graphite website. I've said right-click, new tab, and I've changed. This is, let's imagine that this is the original. I've said, hey, Graphite, I want to, and I did this twice so you could see regexes are supported here, and type blobs. So I could have said, instead of target equals router 1 bytes and target equals router 2 bytes, I could have said target equals router 1 or 2 bytes. I would have got the same graph. So here we see the problem I was describing before. All data is of type gauge. So when we graph this, we're just going to have a counter variable that's kind of going up into infinity. It's not very useful. If we want to get what if we want to get what RRD tool normally gives us, we have to wrap these data sets in functions. So I'm going to wrap this in a derive function. And I know how that sounds to you right now. I do, because I was totally there. I was like, oh man, really? Wrapping a derive? That's stupid. Just bear with me for a second. There are a whole bunch of these functions, and they are absolutely beautiful. And the first illustration I have of that is this graph on the bottom. And so what I've done is I've said, well, it's nice to have rate interface, or rate information, right? It's what we're used to seeing. It's cool. But you know, that counter graph, that counter data graph is actually pretty cool. It's not useful because the router counters started at different variables. If they had both started at 0, I could actually see a difference in the rate of growth between those two counters. But since one started at 25,142 and the other started at 14,000 something something, I get two very different lines, right? So what if I told Graphite on this bottom graph, you can see here, I'm saying, hey, I'm going to go ahead and wrap this router 2 data set in a second y-axis function, right? So basically all I've said is, hey, I want a second y-axis for the second counter. And so now you can see it you hopefully can see it. It's over here. And now we have basically a fair graph. It doesn't matter where they started. They both functionally started at 0. And now Graphite is tracking them on two different y-axes, the blue line over here and the green line over there. And I can see, yeah, look, they diverge right here. That's interesting. And there's different sorts of rates of growth in here. And it's kind of fascinating. And think about this. How would you have drawn that graph in RRD tool? To draw that graph in RRD tool, you have to take counter data and derive the integral in reverse Polish notation. Exactly. Right? Am I alone on there? Is that just me? It's like, that's an impossible graph. I mean, it's probably not impossible. I mean, I'm sure one of you maybe or somebody out there could do it, but I'm not going to do that. I mean, that's not fun for me. And having done it, I'm never going to do it again. Like I'm never going to go back and I'm not going to. Where am I going to set that up? And in one of my interfaces says, here's how you get the draw. God, I can't even imagine, right? So here are some more interesting ones. So here on the top we have a graph of the number of user registrations on a website per minute. And then what I'm doing immediately is I'm saying, I'm imagining to myself, I'm sure there was another scenario I was supposed to read to you there, but I'm imagining to myself, well, this is a sales team and they're trying to get people to register for their website and they're goals-based because they're sales guys. And what they really need to see instead of registrations per minute, even though that's how you're measuring it, is registrations per hour. So what I've done is I've wrapped the data set, user registrations, in a summarize function, and I've re-summarized the data to be 1 hour slots instead of 1 minute slots. Down here, I've added a threshold to it by wrapping the entire thing, or by just adding another target and calling it threshold, using a threshold function. And then down here, I'm time shifting the first data set. So I have 3 targets. I have target 1, which is my data summarized. Target 2 is the time-shifted data from, where is it from? Summarized from 30 days ago, right there. And notice I'm actually wrapping it summarized. So those are recursive functions there. I'm time-shifting the summary of user registrations per hour 30 days ago, right? And then I'm going ahead with my third data set and adding that threshold back so they can see how they're doing. And I can't tell you all the functions because there are a lot of them and they're all very, very cool. Pretty much anything you can imagine statistically is out there. There is an integral function, so you can go back from rate if you want. There's all kinds of summarizing by the max number of hosts or max number of whatever units and min number of units. Like I could take user registrations and wrap it in a min 10 function and get back just plotted the 10 fewest, right? It really encourages you to go out there and ask your data questions and sort of figure out answers. It's a beautiful tool. That's it. So summarizing, in summary, there are a lot of ways to skin the cat. What we're all doing right now, I think, is awesome. I love to see time series visualization. I think we're all doing it pretty well. I wanted everybody to be aware of Ganglia and Graphite. Ganglia is a really awesome way to offload time series data from your Nagios server. Graphite is a great way to set up an enterprise-sized, centralized repository of metrics from any source you want, including Nagios and Graphite and Ganglia. And last but not least, if you see any of those books, buy them. If you buy either of these two books, I get $4. And if you buy that book, you're helping some lucky kid go to college in San Francisco. So questions, comments, points of clarification?
Hello? Oh, okay. I think it's tuple.
Is it? Thank you. Where were you, man?
I don't know. I wanted to watch you flounder a little bit, I guess. Tuple. Yeah. I don't know. Maybe I'm wrong too. But question about GWeb. So is it just a visualization tool for Ganglia, or are you able to do, like, are you managing your Ganglia infrastructure from GWeb? Like, what does GWeb all do besides just display graph stuff for RRD tool?
Let me consider that for a second. I'm pretty sure it's just a web front end for Ganglia. I don't think you're like reconfiguring gmetad or anything from the GWeb website.
So it's just to get visualization data from RRD tool? Like, could you, I guess the question really on my mind is, could I put GWeb in place instead of something else to get data from RRDs, like from anywhere, right? Like I just have a directory full of RRDs and I put GWeb somewhere and I don't have a full Ganglia install, and I still am able to use like the stuff that it does to visualize things.
It makes some assumptions about the file system, right? So it makes some assumptions about where the files are and how the hierarchy works. Like because Ganglia makes the assumption that your hosts are separated into clusters, GWeb expects to see a file system that has top-level cluster name and then hosts beneath it. And it's going to visualize those hosts as if they were within machine clusters. But other than that, it would work fine, yeah. Yeah, it's one of my oldest gripes with any of the RRD tool front ends is the inflexibility and the assumptions they make. I really, 5 years ago, we were building tools like Cacti, you know, and everything was completely integrated, and you know, Cacti was all you ever needed, and it was all you were ever going to use, and that's it. And today, I think we're making tools like Graphite because the tools people are realizing that there is no single solution for everybody, that we all want to have multiple tools, we all want to tie them together. And seeing a thing that is a front end make assumptions about where your RRD tools and how, or where your RRDs are and how you're using them is distressing in 2012. But in GWeb's particular case, there is actually kind of a pretty good reason for why they're making the assumptions that they're making, because ostensibly they're making a tool to monitor grids and machine clusters. Not that you have to use it for that, but those assumptions are there, for better or worse.
I got one concerning how to get the data into Graphite. Let's say I have my friendly scripts there, and today I have them wrapped by Cacti because I'm using RRD2. Okay. And let's say I want them to go into Graphite. Can you comment on what would that entail?
One more time with the toolchain?
Okay, let's say I have scripts today. Okay,
so they're like MRTG style?
No, SH or Perl or whatever. But my point is not the script, is that they're using Cacti just for the RRD2 so that I can get my data there and then, of course, be graphed. Okay.
If you had asked me anything other than Cacti, I probably would have had a ready answer for you. But like I just said, Cacti is a really difficult tool to get data out of.
MRTG then. Let's say I have them just using MRTG.
I would, even with Cacti, I would probably attack the script before you get to Cacti. I would, whatever your polar is, or whatever, if you have something between your polar and cacti, you could insert a one-liner shell. You can use netcat. I'm surprised I didn't put that on the slide somewhere, but yeah, you can use netcat, and all you have to do is parse out from whatever your polar was. You parse out the date stamp in epoch seconds format. You give it a name, and then take that metric, space separated, single quoted, and put them in a netcat command, netcat-c, so it doesn't respond, and just toss it to carbon, the IP address of carbon, on UDP port. I don't remember off the top of my head. Anyone? And it'll get sucked right in.
Okay.
Any popular programming language out there, Ruby, PHP, Java, all of these languages have built-in functions that do it to the extent that you import the library and then you just say carbon.send your metric and pretty much it gets handled for you.
Okay. Thank you.
Hi again.
Hey.
So my question is, so it seems easy enough to say, okay, I want to make the switch from RRD tool to graphite, and instead of just stuffing my data into RRDs, I just send it to Carbon, and it does it does the magic to make that happen. Let's say I have years and years worth of data in RRDs, and I want to move that data from RRDs into graphite so I don't lose any of that historical data that I've already collected for however long. Do you know of any tools that let you do that?
Yeah, I mean, I've done it. We did it just to get historical data from Ganglia to graphite. And let me just say before I answer that question, in my limited experience, very few people seem to be going from RD tool to graphite. Most people are just adding graphite on top and using it for different stuff. But yeah, I've done that, and you can pretty much do. You can script it. I don't know of any tools. I scripted it myself with RRD tool fetch combined with Whisper. There's a Whisper command line tool, and yeah, just piping across one to the other. The only problem is, obviously matching the metric names to what graphite expects. But generally speaking, graphite is a lot nicer about data import and export than RRD tool is.
Yeah.
Part of that comes from the time agnosticism. You don't have to worry about sending it data in order or anything like that. I mean, you can completely send it, out of order timestamps from 10 years ago, and it doesn't care. It'll deal with it.
Right.
Yeah, I don't know of any tools off the top of my head.
Does graphite have the same visualization options that Ganglia does? Like you can overlap two graphs, or you could do like trend analysis and stuff.
So yes, graphite is way better about data display because it's not stuck with the data being in RRDs. I don't know if any of you guys, or if you specifically have actually done the command line to run RRD tool graph. It's enormous. It's a lot of options. It's very verbose syntax, and as a result, I'm doing a lot of RRD tool bashing. I love RRD tool. Just so forgive me, Tobias, but it's much more difficult to script a front end to an RRD than it is to a Whisper database because of the functions. The functions exist to do pretty much whatever data visualization you want in Graphite. RRD tool, it's also possible, but it's not easy, which is why having a really good front end is so important. Does that kind of answer your question? Yeah, you won't be losing any Nito visualization going from one to the other. You'll be gaining. It'll be a net gain for you. To the bar.
That's it? No questions? First of all, my apologies for missing your introduction, Dave. I took a nap and I woke up a little late. We have BOF sessions in here in this room from 6 to 10, so check the board, and if there's somebody you want to talk about something to, make sure you hook up with them later. So 6 to 10 in this room, okay? Guys, have a great night, and we'll see you tomorrow morning. Dave Josephsen.